There's a test design approach that actually looks at software designed to help design tests, and it's popular in a lot of different industries. It's called failure mode analysis. And the failure mode analysis is not something that was invented in the software world, and it's more applied in hardware or in manufacturing. But it does show up once in a while, and there are many non-technical executive stakeholders that sort of like a failure mode analysis and like people to do a little bit of testing modeled like this. So I just want to walk you through how it would work in a system where you have a good idea of the design of the system under test and a good idea of the usage of the system under test. So you'd start this analysis basically by creating a block diagram, some sort of block diagram of the design. Then we're going to classify the users, identify different categories of users of the system. Looking at the block diagram, we're going to find elements which can fail. And then working with our architects, we're going to complete a table, which is a usage failure table, which shows the impact of a failure of a subsystem or a block in our block diagram on a usage scenario. So does this failure, could it impact this usage scenario? And then what we would do is we'd sort of rank the potential failure impacts and then design experiments to simulate the failures and to see if we recover from them in a way that doesn't lose transactions, that's graceful, and that doesn't interfere with the user's experience. And we try to do this basically on things that have a pretty high impact. So to create a block diagram, this is a beautiful visualization used in software architecture quite a bit. Blocks represent just elements of a system, subsystems, or processes. And connectors represent a logical or physical relationship or an invocation relationship between elements of the system, so between blocks. So there's basically blocks, which are drawn with like rectangles, and connectors, which are arrows. Then we have the object, the list of the class of users. So this is who is the users and what are they doing? We can break that down into categories, like we can say these are administrative users, these are end users, these are subject matter experts, these are accountants, these are managers. We can create personas, so we can create actual histories of users and say this is Fred the user, this is Joe the plumber, this is all the different personas, and map those. And we can also keep track of the context. There's when is the user doing it. So is this something that happens to a bank teller at the end of a month? Or is this something that happens to an auditor at the end of a year? So there's context factors, time, business circumstances, etc. Now, we look at the elements that are in blocks in our system, and we ask the question, which ones can fail? You might think that anything can fail, and it's true, anything can fail, but we want to still look at certain types of failures. For example, does this piece of software depend on a resource which might not be there? Does it depend on a connection that might not be there? Does it depend on some resource that may be limited or constrained? So we look at elements maybe also with a history and saying, aha, this does crash frequently. This is insensitive to corrupt data or something like that, not resilient. So we find elements which can fail. Almost all of them can fail, by the way, so it's not tricky. We create the usage failure table with the interesting blocks. So these are the blocks that we really were concerned about. And the mapping basically has, so basically the rows would be usage scenarios and the columns would be blocks in our diagram. And then we basically rank failure impacts. So this table with five severity levels actually common in failure mode and effect analysis textbooks. So you'd say S0, severity 0, there's no impact. So if this element fails, this user can still do their job. So if the wrapping engine fails, well, the loader can still load the chocolates. So there's no impact. Then S1 is showstopper. We have an impact that the user cannot accomplish their tasks. So if their task is important for the business and this type of failure happens, that user cannot do their job. That's a showstopper. There's no workaround. They can accomplish some of their work, but not a particular one. a workaround. They can accomplish their task, but they have to do something tricky to get around it. And cosmetic would mean there's maybe some inconvenience. So those are the different severity levels. And if you were to implement this, it would be a very good idea for your team to build up a catalog of examples so that we could be very specific about what's the difference between an S2 and S3, etc. I'll give you the example for the Wrap-O-Matic, the fictitious chocolate wrapping device. So just to show you, this diagram is a block diagram of the Wrap-O-Matic. The blue boxes represent process elements within our control. The yellow blocks are outside of our control, so the blue ones are perhaps the ones of interest to us. We built this table, which is a table of failure modes. If you see all of the users, the operator, loader, auditor, inspector, maintainer, so there's one row for each usage scenario, what they do, so who's the user and what do they do, and each of those blue blocks, which represent process elements, are given a column. And then with discussions with our architects, we asked the question, well, if this device, if this column failed, what would be the impact on the user? And we categorize that therefore as S0, S1, S2, S3, S4. So this table is actually, if you look at it, it's a pretty sparse matrix with a lot of zeros in them. But once in a while, you see interesting chains. Like, for example, error reporting here has a lot of S2s here. That's an interesting thing. So there's some things that really impact that. And if you look down here, there might be some features that touch a lot of users. So if you look at maybe this one here, the controller, if the controller fails, look at all sorts of things can't be done with different severities. Where are the S1s in here? You might want to hunt them down. Unloader unboxing chocolates is a lot of S1s. So you'll find basically the usage scenarios which you want to study when simulating failures. So you might want to simulate the material manager software failing in the middle of, for example, an auditor looking at error reports or a unloader looking at rejected chocolate. So these are things that define the experiments that you want to run to make sure that the failure is manageable if it does occur. So this is a failure mode and effect analysis. It's looking and trying to find weakness and places of consequence that might be weak, and then basically doing experiments to see if we can improve the quality of the system so that we have better error recovery. So that's the type of thing we'll do with failure mode analysis. And I'll just stop there and thank you very much.